get started today. This is section 9.1. This is the beginning of the last chapter of the year. We have 50 days of school left. Spring is next Wednesday, I believe. Today's topic of discussion is 9.1, quadratic functions. This is the introduction to this chapter. It is very intensive. The first section is very intensive. However, it is not difficult because we will actually be going over it pretty individually. I do have some notes, part 1 notes here typed out. Please do not use it. You will use this a lot next year in high school. And this will be used for homework. If you need a calculator or some homework, please let me know. I'll give you one. Okay. I'm going to show you a couple of things today on the calculator that you will be using. I think some of you guys will be very excited about it because it will save a lot of time. But this first section is all about solving it by hand. Of course, we're going to go through each step. Okay, so don't freak out yet. This will all come together in about 3 weeks. So I just typed it on one paper so that you had it in a neat place. That makes sense? Any questions so far? Alright, Sergio, you ready? Here we go. Quadratic functions. Q, U, A, D, R, A, T, I, C, F, U, N, C, T, I, O, N, S. Quadratic functions. This chapter is all about the lines. No, the lines that become U-shaped. These are all U-shaped graphs. That is x squared, you're right. U-shaped parabola, x squared. Okay, everything here is all U's. No lines, all U's. Okay, so your graphs are wrong if it's nothing but a U. F of x equals x squared, or y equals x squared. How do you know from looking at an equation that it's a U-shaped graph? What gives it away? The x squared. The x squared. It creates a mirror image on both sides of the U. The points are exactly the same, but just opposite signs. So if you have a point of 2, 0, it'll be negative 2, 0. If you have one that's 1, 4, it'll be negative 1, 4. It's going to be mirrored on both sides. So we know it is a U if it has an x squared anywhere in the problem. It is also called a parabola. It's not a disease. Parabola. P-A-R-A-B-O-L-A. P-A-R-A-B-O-L-A. Yes, parabola. You have the parabola. You're linear? Okay. Parabolas could be opening up. It could be a positive. Y equals x squared. It could be happy. Positive, happy. It could be sad. It could be negative. It could open down. Y equals negative x squared. Guess what those are called? These equations right here. Well, they start at 0, 0. It's one of your family members. It's your mother function. There is your mother or your parent function. It's your mother or your parent function. Parabolas. 0, 0, y equals x squared, y equals negative x squared. Okay? There's a lot of things. This is college level math right here, so it's going to be a little tricky today. Yes. We'll be graphing it by hand first and then strictly on calculators after. Okay? Now, let me zoom out here. Let's go to the very top here. First things first, I want to go over how to tell whether or not it's a U or not a U. Let's pretend that you're not given a graph, you're only given a table. 1, 2, 3, 4, 5. That's all you're given. 1, 2, 3, 4, 5. And you're given your y values 0, 3, 8, 15, and 24. Now, do you want to graph those points? No, I don't want to. I'm going to show you how to find out whether it's a line or whether it's a U. Here's what you do. You take the first difference. You take the first differences. Now, what does that mean? Well, what does the word difference mean in math? You subtract or you add. Well, subtract, you want to figure out the differences between the two numbers, right? Now, what does that start? Well, look at your x. How does 1 become 2? Add 1. Well, how does 2 become 3? 3 become 4? 4 become 5. First differences. How does 0 become 3? Plus 3. And 3 become 8? 8 become 15? And 15, 24? Alright. That doesn't tell you anything. And increasing, but to find out whether it's a U or not, take the second difference. Why? Because it must be the same number and consistent for it to be a U. So how does 1 become 1? Do you have to add anything? So pretty much it's like 0, 0, and 0, right? Well, how does 3 become 5? Plus 2. How does 5 become 7? And 7 become 9? Because the second differences are the same, it is a parabola. Okay? So because the second differences are consistent, it is a parabola. So you can easily just do that by just looking at the graph or using a calculator or going to your table or graphing it. Now, later on I'm going to show you, probably tomorrow, I'm going to show you how to type in points in the calculator. What am I talking about? I'll show you. I'm going to show you just a snippet of what we're doing here. You see these points right here? I'm going to show you how to type. Now, some teachers might not like me doing this, but I'm going to show you anyways because you need to know how to do this. Okay? Just as a reference tool for you. Now, see this stat button right here? Stat. See where it says edit? See this table right here? That's where you enter in your x values. 1, 2, 3, 4, 5. What are your y values? What are your ranges? 0, 3, 8, 15, 24. The calculator can actually find and tell you the equation of the line without you ever solving for the slope by using the points. Go back to stat. See where it says calc? See all these options you have? Guess what number 4 is? The line. Guess what number 5 is? Quadratic. What option do you use to figure out if it's a U? 5. Quadratic. Press enter. There's your equation. What's your equation? Any guesses on the equation? X. Keep going. X squared minus 1, because 0 doesn't count, right? So you leave 0 off. X squared minus 1. C is 1, right? Does this kind of make sense? We'll practice this again. See how Z is, Sergio, see how C is negative 1? So what's your equation here? Y equals x squared minus 1. Guess what? X squared minus 1, when you graph it, there's your U. Guess what? Go to your table. All of those points are present. You can use for lines, use for anything. There's a little trick for you there. We'll practice this more. You can do, well, tonight's not where I want you by hand, but later on, yes, you can, of course. Quiz, test, I don't mind. But I want you to know how to do it by hand first. Okay? But I'll show you more of that as we go. Okay, continuing on. Let's graph the next one by hand, please, so that you know kind of where to start. Okay. For the first example, we're going to graph a parabola. We're going to graph a positive parabola that opens up. What's your mother function? Y equals x squared. The vertex, Sergio, what's the vertex here? What's the bottommost point? 0, 0, excellent, 0, 0. And it's obviously it's U-shaped. Okay. We're going to make a table by hand because it's on your homework and you need to practice this. This is new. Your equation is f of x equals x squared minus 4. I want you to find the y and find the point of x and y, the coordinate point. Now, think back to chapter 5 when we were graphing lines. They did not give us any points for x, any domains. Therefore, we have to have points. We have to make our own x values. Which do we choose? -2, -1, 0, 1, and 2. Okay? You always pick 2 negatives, you pick 0, you pick 2 positives. That's just a rule of thumb. Now, starting with -2. I need to do some substitution here. I'm substituting -2 in place for x. I have -2 parentheses 2 squared minus 4. -2 squared, Jackie. Positive 4 minus 4 is 0. So your first point is -2, 0. -1. -1 squared minus 4. -1 squared ever? 1 minus 4? -3. Next point is -1, -3. 0. 0 squared minus 4. Emily? 0 minus 4? -4. 0, -4. 1. 1 squared. Hannah? 1 squared. 1 squared is 1 minus 4 is -3, right? 1, -3. And the last one, Toby Lee, 2 squared minus 4. 0, so 2, 0. Let's talk about the characteristics so far. Remember we talked about how it's a U-shaped and they have to mirror each other? Well, what do you notice about those points? It's got pretty much it's the opposite sign. They have to be mirror points on each side, right? It creates a reflection. The U is cut in the middle. What's the bottommost point? Yes. Look a little closer. Anna, what's the bottommost point? Now, 0, -4. That's the minimum point. Yes, sir. V is absolute value. We don't talk about those graphs until algebra 2. But yes, it also mirrors too. But this is going to be same type, yes. Okay. So 0, -4 is your minimum point here. So when we graph this using a quick sketch, let's review our quick sketches. Space out your hash marks, arrows in the end to denote that they go on forever. You're graphing your points, -2, 0, -1, -3, 0, 4, 1, -3, to 0. Remember, it's a U, so make it look like a U. For you artistes out there, should be easy for you. So make it a U. Okay. Now, let's label the points that we know. What's this point right here called? The bottommost point. Okay, later on it's going to be called the minimum. What are these points right here called? No. Pretend that's a parabola plant. It's shooting out from the ground with x-axis. What's supporting it? The root. Louder? The roots. Okay. The roots. That's the roots. These are the roots. Negative 2, 0, 2, 0. Where is it split down the middle? Where is the mirror point? Where do I put my mirror on? Where's the line? Where am I putting the line on? What x value? What x value am I splitting it right down the middle? 0. Guess what? This will be called your reflection line, right? X equals 0. Okay. So that's a little bit later. Let's go back to chapter 8 really fast. What was your original equation? What did we just fix, or graph? X squared minus 4. Okay, go back to chapter 8. What two parentheses makes up that equation? X plus 2, x minus 2, correct? Guess what? If you solve each one for 0, guess what you have? You have your roots. These are your roots. So every time we factored last time in chapter 8, we were solving for the roots. Every time. Last time I tutored Algebra 2, this is what we did. We factored the roots, and that's what we did. We solved for the roots, and we figured out where they were. So I can do 2 factoring. We set it equals 0, we get the 2 roots. So every time you factor any equation out, it's where the roots are sprouting from the x-axis. This is fun. This is not easy. This is college algebra. This is the math. Last chapter, people. Enjoy it. Okay. Any questions so far? We're not done yet. We have lots more. That's great. Okay. Here we go. Now, we talked about how to graph a graph a parabola. Now, let's talk about the different characteristics of it. Now, perhaps you're wondering, how do we know if it's a positive parabola? Yes. Nope. You're looking strictly at the algebra part of it. Cute, no. Close though. Okay, if you have ax squared plus bx plus c, I know it's positive looking at the algebraic equation by checking out the a. Check out its a. Okay. That's a nice a. If the a is positive, if the a is positive, it is always positive. So if the a is positive, it opens up. Okay? If the a is positive, it opens up. Always. Y equals x squared. If the a is positive, it opens up. It's a happy a. What? Not true? Okay, so what happens if a is greater than 1? You have a really large a. It's more than 1. What? I'm not laughing. I don't think it's funny. If a is greater, get me in trouble. greater than 1. If a is greater than 1, if a is like 2x squared, 5x squared, 9x squared, if it's more than 1, it is always narrow. It's narrow. It's narrower. It's being vertically stretched. Okay. It's a vertical stretch. You're stretching the A out.
He's doing it now.
Alright, now the A is being stretched, so if you have an example as such, f of x equals 5x squared plus 6, you're comparing everything to your mother function. Okay, what's your mother function's A? Well, what is it? What's your mother function? No. What's your mother function? It's just x squared, right? Okay. If your A is 5, is it going to be within or outside of the mother function? Sergio, what do you think? Is this equation going to be inside or outside of your mother function? It's going to be inside. Right? So if your mother function is x squared, your 5x squared is within. It's going to be stretched. It's stretched on the inside, 5x squared. So if your equation has an a greater than 1, it is bigger than your mother function, it's going to be within the mother function, stretched within. Okay? Okay. Okay, moving on. I don't have no idea why you're referencing that. Alright. What happens if your A, so the opposite, if the A is greater than 1, it's being stretched. If the A is less than 1, it is wider. Wider. It's being, hi freakos. It's being horizontally stretched. Oops, wrong one. It's a horizontal stretch. Stretch. Okay. What does that mean? Well, again, if you have an equation like f of x equals 3/4 x squared minus 7, again, look at the A. You're comparing it to your mother function. So, if you have your mother function, if it's x squared like this, okay? Stephen, what's your A here in this equation? 3/4. Because it's a fraction, is it wider or narrower than your mother function? It's wider. It's a wide mother function. Or wider than your mother function. So it's going to be outside of the mother function here. So this would be 3/4 x squared. Another way to kind of remember it is you have, if you have a fraction, you have a fat parabola. Fat fraction, because your slope is not as steep, right? So it makes it kind of wide. If the slope is really steep like this, it makes it very narrow. Does that make sense? Yeah. If you have a really tall slope, it's stretched out. If you have a fraction, it's much wider. So, yes. Any questions so far? It's starting to make sense. It's fun. I hope it makes sense to you. Alright, we're almost done. Almost done. Oh, we gotta hurry. Alright. Now, we talked about opening parabolas that open down, up. What about parabolas that open down? Open down. Opens down. Opens down.
Oh, man.
What?
I should ruin
Doesn't matter. So, all these parabolas, it's negative ax squared plus bx plus c. So you're going to be paying attention to the Still the A. The A is negative. Negative 5x squared, negative 4x squared, negative 3/2 x squared. The negative A gives you a sad parabola. It's sad. It's negative. So it's negative x squared. Now, again, keep in mind that you're going to be finding the absolute value, the distance from 0 of A. That will tell you whether it's wider or narrower. What does that mean? For example, y equals negative 3x squared minus 1. So here, y equals negative 3x squared minus 1. Aisha, what's my A? A is negative 3. What's the absolute value of negative 3, the distance from 0 ever? How far is negative 3 from 0? 3. Think back to what we just talked about earlier. We know that the A, if the A is negative, the mother function will open down at negative x squared. If the A has an absolute value of 3, usually always positive, right? It's going to be narrower, okay? It's going to be narrower because it's greater than 1. So it's going to be within the mother function, negative 3x squared. It opens inside because the slope is much more. Again, with practice it makes sense. And then if you have Seth, no. If you have a fraction, negative a, it's the same thing. Okay? So the a here in this case, if you have negative 5, 6x squared plus 2x, you're looking at the a here. You're looking at the a. Leslie, what's your a here? Negative 5, 6. What's the absolute value of negative 5, 6? How far is it from 0? 5 over 6. Because if the fraction, if you do your mother function here, it opens down. I'm comparing it to your mother function. Is it going to be wider or narrower than your mother function? Wider. Opens up wider. So it'll be negative 5, 6x squared. It opens up wider. Right. Greater than 1, narrow. If it's a fat fraction, it's fatter. Absolute value of negative 5, 6 is 5, 6. That's not greater than 1. That's less than 1. So it's wider. What if it's 1? Then it's your mother function. We'll talk about how it shifts up and down. But now we're talking about how narrow and wide they are. Later on we'll talk about shifts. We're not done yet. Shifts, not the other one. Somebody said it, yes. Vertex. I'm not done yet. Vertex. It's the highest or the lowest point in a parabola. The highest or the lowest point in a parabola. The highest or the lowest point. You gotta hurry. So if I have a minimum, Latin students, you should know this. Cute. No. Minimum point. Think about what kind of U will have a minimum point. What kind of U will have a lowest point? No. A positive, right? It's only for positive parabolas only. It's going to have a minimum point. And then a maximum has a maximum only has a what kind of parabolas? Yeah, this is only for negative parabolas only. Because it has at most or at max points. Minimum, maximum, again, it will become second nature to you when we practice. Domain and range. domain is what values? And ranges are y. Okay, let me give you a little hint here for this chapter. All your domains will be all real numbers for all your answers. Just an FY for you. Yes, I will. So if it's asking for the domain, it'll be all real numbers. We'll explain it later. All real numbers. Okay? Look specifically at this problem. If we know the ranges are all your y values, what is the maximum? Is this maximum right here? I'm sorry. This is maximum, correct? What's our highest y value? What's the highest y value? 4. Can it be exactly 4? Can it be more than 4? No. Y is less than 4. Domain will be all real numbers for this chapter. No.
It looks like we're out of time.
Okay. Now, we'll do day 2 tomorrow. On your homework tonight, do all of this. It's not hard. 1 and 2, find the differences. 3, graph. 4 and 5, up or down by looking at it. 6, 7, 8, we just did it. Identify minimum, max, find the domain and range. On the back page, same thing. Number 3 and 4, you're graphing it. Draw the U. 5 and 6, up or down. 7 and 8, identify the vertex, the minimax, and the range. Simple, not hard. Substitute paperwork. If you need to, you can go by. Say goodbye, YouTube. Bye!